So yeah, good evening, Prague, and thanks for joining this session. As Gerard mentioned, my name is Alex. I'm an open source engineer at Teleport, a startup from Cluj. And I'm also the co-founder of JS Heroes, which is the biggest JavaScript community in Romania and one of the biggest conferences that we're doing every April. So if you want to join us next April, do look me up after this, as we have some discount links as we're partnering up with ReactiveConf. And also, if I tried to arrange my slides after the tech check, I saw that there's a thing in the middle. I tried to arrange my slides so that you can see the content, but if you find any problems, there's bit.ly/reactive-alex. You can follow along with the slides. And also, there are a bunch of links there which you can access later. So you don't need to bother to take pictures while this is on. So we're going to talk about performance. And performance is a topic very dear to me. And I would like to start by trying to. So let's focus first on what is our objective, right, as a web developer when we talk about performance. So what we need to do is to get to offer to the users a way by which they load about the browser, they go to the website, and they get back and they see something, right? The rendering is happening, they get to interact with the page, and they have overall a delightful experience. So there are a couple of steps to this, and this is part of what we do when we talk about performance optimization. But I like to think of performance as seen on two different dimensions. We have the context and we have the process. And I think we should start by that before we actually get into the deep technical part. So context is about all the external dependencies that are affecting our objective, right? Remember, our objective is to load the page as soon as possible to make it interactive and so on. So external dependencies can be browsers, can be your network speed, can be the device that the users have and the device that they are using to load up your page. And this context can be problematic because of course you cannot really do much about it, right? You cannot upgrade the network speed of your users, or you cannot improve their devices. So this is one thing where you need to be fully aware of, right? You need to test in different scenarios, different combinations, right? Test on 3G networks, test on low-end devices. Because context can differ a lot, whether you're in Romania or in other countries in the world. And I'm pointing out Romania not because it's just my home country, it's because we have some of the fastest and cheapest internet in the world. But there are other places in the world where, unfortunately, internet can be quite expensive and speeds can be quite low, and also devices are not always the latest generation. But we have this notion, we have this problem of thinking inside our box as a developer. So we say, okay, sure, my MacBook is running this website fine, so I don't need to make myself, I don't need to have extra problems just testing it out on different devices. This is the context, but we also have the process. The process is the way in which the browsers actually work. We need to thoroughly understand this process in order to be able to act on performance. And again, here we have sort of like, we have this problem of thinking that the browsers are like a multi-lane highway, right? We need to get from A to B, and it just goes fast, right? The browser is fast. We start from this assumption. But I think, so I like to think of browsers as more like busy cities with a lot of intersections and with a lot of streetlights. So you as a developer actually have access to those streetlights. And if you do your job well, then maybe some of the streetlights are green by the time the browser gets there. So the browser will be able to actually go fast from A to B. But in other cases, maybe those streetlights are red. So then the browser has to wait and has to stop everything and has to wait for something else to happen. And whenever there's a red light, we happen to talk about something called a critical resource in our in our application actually. So why I wanted to put this first into the context and the process to bring it in front of you is because they are part of like this performance mindset that we need to have, right? We need to be aware of where are our users, how are they using the application, how am I taking care of the whole process, and how are things, if things are streamlined enough or not. And in order to, the main problem with performance is that you say, okay, I understand now that my application is slow or that I can actually do something to improve the performance, but where do I start? And you get online and you start going through these terms like time to first byte, time to interactive first meaningful paint, speed index, and you're like, okay, I have no idea how to start actually. I have no idea what these mean and how I can actually represent this based on what I currently know about how a website works or how browsers work. So let's dig into that a bit. If you look at an application, I need to find my cursor. Yeah. So if you look at an application, you see that there are different stages, right? This is the Twitter, the mobile version of the Twitter web app, and you see it's running on 3G. It's not exactly fast, right? It took around 10 seconds to actually show something. So if we were to go over this again, you see intermediary steps. Right now we have just the spinner. Now we have some content at the top. Now we wait and we wait and we wait, and only now we have some relevant content for the users, right? Because users want to see tweets when they go to Twitter. They don't want to see just the header. So we have these intermediary steps when loading an application, and let's try to see which are these steps and how do they map to those terms that performance standards are about. So initially we have a blank page, or in this case, because it's a progressive web app, it has the logo, but at this point the user doesn't know that something is happening. They will just assume that they might assume actually that the website is not working at all if you just display a blank page. At a certain point, they have the first paint when they actually see something. You will not see here, but there's a spinner in the middle. This is the first time that the user has some indication that the operation that they requested, loading the page, actually worked, or is working, is in progress somehow. Then at a certain point, we have some content being displayed. This is called the first contentful paint because at this point, a first element that the browser considers to be content, like text, like links, like anything that the browser considers content is being displayed. So we have probably we have some fonts already loaded, and we have the main layout in place. After that, we get to this very important step called the first meaningful paint, on which we are going to focus a bit today. Because this is the first time that the user actually sees what they perceive as the actual application. So the layout is pretty much there. It might be missing some content, it might be missing some images, and especially in Twitter's case, that might be relevant because there are a lot of images that are being shared. But nevertheless, the user will see this as the application being ready. They will have this perceived performance, this is how it's actually called, that the browser already loaded the application. So it's crucial to get this first meaningful paint as soon as possible to our users. One problem with this is that this is not interactive yet. There's another step called, there's another event called page interactive. And this usually takes time a bit after the initial render because you need to have time to download, parse, and execute JavaScript. And especially in modern web applications, which we're talking about, this can take a lot of time. And finally, we have the page load. So the first 4 frames here are part of the rendering part of performance. This will be our focus for today. The second part is strictly related or mostly related to interactivity, to how fast and how much JavaScript you're actually executing on the browser when the page is loading. And you can actually go to on the main stage at 4 o'clock to Brian's talk, and he will talk specifically about getting your JavaScript to a minimum size and getting that interactivity sooner on web applications. So we're going to focus on the first 4 here. But in order to focus on that, let's actually now get into the technical part. What's happening actually when the browser does a request to the server? So you fetch a page, and just as a parenthesis, this scenario here is the optimal scenario that we're going to see. And then we're going to go through some of the steps that we need to do in order to make sure that this actually happens, and this is even more optimal at the end. So you get, you get the request, and you get back some HTML, right? This is the basic idea of how browser should work. Now, of course, browser cannot really display that HTML at this point because it's just some tags with no style, with no interaction, with no interactivity. This part here is called time to first byte because this is the time you're basically waiting behind a blank screen. The browser has nothing to show you. Now the browser starts parsing HTML, or no, starts from the head, and the browser finds the first external resources. Style sheets, external style sheets, fonts, images, maybe JavaScript. All of these resources which are encountered by the browsers are the red lights that we talked about. Whenever the browser comes to an external resource, they have to stop, wait for the resource to be fetched, and then come back and resume the parsing of the HTML. The browser needs HTML, it needs the CSS to be applied, so the DOM to be created, the CSS OM to be created, to be composed, and to actually be rendered on the screen. Now, so the HTML gets parsed. We ask for CSS, we ask for fonts, any other resources which are critical at this point. This is what we call critical resources, all the resources which are blocking the rendering phase. After a while, all these resources are back, and now the browser starts assembling things together. And this whole period here, this is the most important part that we're going to be focusing on. And this is where all these different steps that we already saw in the screenshots are happening. The first paint, the first contentful paint, the first meaningful paint. So now we get JavaScript. Now we start making AJAX calls, and we start populating the rest of the page. And this is the interactivity part, which we're not going to talk about. So again, focus is here on this part here, and focus is basically on making sure that this part is squeezed in as much as possible to the top, from the moment when the HTML is back the first time to the moment when we can have the first meaningful paint, that first render, which is critical for the users to perceive our app as fast. So this is called optimizing the critical rendering path. And the whole point of this talk is then to go through a few ideas of how you can eliminate resources from your path, because the less resources you have on your critical rendering path, the fastest the browser will be able to render something for the user. So first thing we need to do is make sure that JavaScript is off the critical path. But how can we do that when our modern front-end applications are actually relying on JavaScript to render anything, right? Usually our index HTML is a blank page with some references to some bundles, some JavaScript bundles that are kicking everything in and start rendering the page. Well, we do that with server-side rendering. We take advantage of the modern capabilities of frameworks to render in Node. So when the user first fetches the page, does the first request, they will wait a bit longer, but on the server, we will make sure that the page is rendered there. HTML is being built up out of the framework that's running there. So React, Angular, Vue, they all have the capability of doing this, of rendering on the server. So instead of this, which is on the left, instead of waiting behind a spinner or behind an empty page, the user will actually get this. Will get the first meaningful paint much sooner. If you want to learn more about specifically in React. I worked a bit on this, and there's an article I published on doing server-side rendering, which you will find as a link there if you go to the slides. There's a link at the end also with the slides if you didn't get that. But it's a pretty straightforward operation, and it's a huge win for performance. Now that we have our JavaScript, that we don't need our JavaScript at this point. We can only rely on the HTML and CSS that we get from the server. We can further actually just kick out JavaScript from the critical rendering path by using something like the defer attribute, which you can see here. You can also use async in some situations, but the defer attribute will actually allow you to will tell the browser that HTML can be fully parsed, the first meaningful paint or the first render can happen, and only then JavaScript should be executed. You can read more about it also on that link there. Okay, so JavaScript was the first thing. What about fonts? Are fonts a critical resource? The answer to that is yes and no, of course. Fonts are critical because we rely on them heavily. I think almost everyone here in the room uses some sort of web font for their website. So the problem with this is that in some situations, you might have to wait a bit for the fonts to actually load. So you get this strange situation called the flash of invisible text. Your HTML is ready, your CSS is ready, the DOM is fully constructed, but the browser cannot actually show content because the font is not yet loaded. To circumvent this, we can use font display, which is a great trick in CSS. You can actually read more about it on that link. You can understand exactly how each individual option has a different strategy for handling this. But for example, one of the easiest things is to use font display swap. And in that case, when the HTML and the CSS are done, the browser can perform the initial render with the default system font. And then when the web font is ready, that will be replaced on the spot in the background. Okay, we kicked out some resources. Now it's time to see what's left and to prioritize what's left. To say, okay, now we have, I don't know, 5, 6 resources in our critical path. How do we prioritize those? What do we prioritize actually? And first of all, we think about prioritizing, of course, what's in the viewport, right? We think of we have this idea that everything that is above the fold, which is this invisible line that's separating the viewport, like the content that actually is displayed to the user from the content that's not displayed. And we try to prioritize everything above the fold. And above the fold, we can do things like inlining critical CSS, where critical CSS is extracted from the global CSS and can be inlined into your HTML. So you avoid another round trip to the server as the HTML is being parsed. You can lazy load images because images are pretty much the heaviest thing that you have in web applications today. And all the images which are not in the viewport, you can actually load them progressively as the user starts scrolling. We'll talk about images on the next slide, actually. But we can also think of the entire page being progressively loaded, because we have today things like dynamic imports when we use something like Webpack. So we will be able to load parts of the application as the user scrolls. And of course, even in the React community now, we have a lot of activity behind the new developments, and the Suspense API is doing exactly that. It's offering you a way to lazy load parts of your content, parts of your application. A few tools that you can look up. Adios Mani wrote a library for extracting critical CSS, which you can use in your application. And also, there's a React Loadable. It's a very nice, quick library which you can use for your React application to make that progressive load of parts of the application. So we talked about images. Now, the main problem with images is that, again, we are not thinking about the context. We say, OK, the browser loads on this display. We never think that on a full HD image can load on a 360 pixels screen. So you have 200, 300 kilobytes of data for nothing because the user doesn't actually see what's the difference between a full HD and a regular image resolution on such a small device. And in order to do that, of course, it takes a bit of effort, but it's extremely rewarding for the overall performance, because images can be in the critical path. I mean, images can be meaningful. That's the whole point. We want to optimize what the user sees first. If the website is focused on sharing images, then we would like for the users to see those images as soon as possible. Further, you can, of course, lazy load images because you might not need them. Might not need images which are, I don't know, behind carousels, or like the 12th image in a carousel might not be needed to be downloaded, even if it is in the viewport. And my favorite one, you can use modern encoding. Unfortunately, here there's not a single encoding that works across browsers, but there's WebP in Chrome. There's JPEG 2000, I think, in Firefox. Each browser supports some form of modern encoding, which will get your JPEG twice as small and maintaining the quality. And you can use something like the picture tag to actually load different formats of images, similar with how you use videos. Lazy Sizes is a great library for image optimization, which I highly recommend, which should be the starting point. And also there's this ebook, Image Guides, again by Adi Osmani, where they go over a lot of these image optimization techniques. OK, now we go to resource hints. Now that we managed to prioritize some of the things, let's try to fine tweak some other stuff here. For example, we can use this new spec called link rel preload, not see there, to tell the browser that, hey, I'm going to use this resource, so make sure that you load it as soon as you can. This is just the beginning. You can see there you can preload fonts, you can preload pretty much any resource that can go in a link tag. The nice part, you can also preload script files also. The nice part is this is evolving into a newer spec that's going to land in HTML sometime in the future, where you will be able to use this attribute of importance. And you will be able to manually tell the browser that, OK, these resources are more important than these. What all of these do is that they actually manipulate this priority here. In Chrome DevTools, you will be able to see the priority in your network tab if you toggle it on. And you will be able to see how the browser by default assigns some priorities to your resources. But with link preload and with the new spec coming in, you will be able to manipulate that even more to be able to fully control how the browser, in which order are the resources being downloaded by the browser. One quick word about third parties. Never have third parties in your critical rendering path, because the moment there's a third party outage, your website will also have an outage, because it will take 60 seconds for the timeout to come back. And meanwhile, the user will stand behind a blank screen because your third party is on the critical rendering path. So always make sure you use defer async for third parties. If possible, make sure you kick them out of the project. This is a funny thing that happened in May when GDPR was released. USA Today, they decided that it's not worth implementing GDPR rules for their website, so they just stripped their European version of the website of all the third parties and all the trackers. So they got down from 5.2 megabytes to 500 kilobytes that was like the payload of the entire website, including images at that point. So yeah, thank you GDPR for making the web faster, I guess. Finally, one quick word When I'm asking this, I'm not going to ask this today, but because I get the same response over and over again. I see people are not using HTTP2 yet. I think it's the single easiest thing that you can actually do in your application, which will improve the performance because you will start getting these parallel downloads of critical resources at a much faster rate than with HTTP1. And it's fully backwards compatible, so at this point, it's been a standard for almost more than 2 years, I think, so you don't need to worry about anything. Just before we wrap, a few tools that you can use to improve performance overall, and this will help you a lot also in gaining more experience about what needs to be done in order to improve performance. First, there's Lighthouse by Google. This is already embedded in Chrome DevTools under the Audit tab. And this is not only about performance, it runs also accessibility, security, and all sorts of other aspects of software quality. It's a great tool to run constantly. GTmetrix is a very nice platform where you can use just to track your waterfall charts, to track a lot of metrics of performance over time. And web page test is, I think, actually the underlying thing that Google uses for Lighthouse also. So this is like the root of performance testing overall. And also there's other tools like SpeedCurve or Calibre, which are more on the business side, let's say, where you can pay a monthly fee, so you can have some constant metrics and dashboards and stuff like that. So, quick recap. We talked about a few tricks to optimize your critical rendering path. And things like server rendering your application, things like prioritizing everything which is above the fold, optimize images, use HTTP2, and so on. There are a couple of links here which you can have a look at when you go on the slides, which either go further from this to some other aspects of performance or simply are getting deeper into some of the things that we discussed today. And one final word is that why I'm trying to present these things and why I think it's important to talk about this is to also get people excited about performance, because it's actually one of the few areas in web development where you actually get to see the improvements day by day, and you get to do this small little tweak and you see a huge improvement for users. So it's very nice, and it's very interesting, and it can be especially a very good thing for the morale of the team to have these performance success stories that people put, the effort that people put behind them. So yeah, thank you very much, and yeah, I'm going to be around for questions after that, because I know I ran a bit over time, so sorry for that. Thank you. Should I do the reading? And yeah, okay. I will just go through one or two questions. I see that I still have 2 more minutes here. So modern encoding, what about older browsers? So you can actually use the picture element, which is a rather new spec of HTML, where inside the picture element you can put different sources. You can put a source for a modern encoding, you can put the source as a default for JPEG, and JPEG is as a default value. So you will, using that, you will be able to improve the performance in browsers that support modern encoding, and you will not affect the browsers that don't support that. Yeah, CSS in JS, I think doesn't really, if it's CSS in JS in the way in which you're actually just writing CSS in JS, but you're building to something like traditional JavaScript and the CSS is separate, then of course there's no problem with that. I'm not sure if I don't have hands-on experience with that, so I won't be able to tell you if that impacts performance in any way. Good practice to learn important libraries, asynchronous or defer. The problem with async is that async does not guarantee that the order in which you put the resources is the order in which they get executed. So if you have some script that depends on something to be executed before that, you will not be able to use async without having some sort of conflict or potential conflicts. Now, I assume that this question is in the context of not necessarily having a modern front-end application driven by a front-end framework, but rather something like Ruby on Rails or PHP. And in that case, I think the whole strategy should be different, because then you will need to rely on some resources in order to load the page faster. And it's a bit a different story than with this, with server-side rendering and with deferring JavaScript. Okay, do I have time for more, or should I? Does anyone want to come on stage and speak something? Okay, let's see. Need tools to generate multiple. Okay, yeah. I only worked in Ruby with something called Dragonfly, which allows you to generate on the spot different resolutions for your images based on the requests that are coming in. But I'm pretty sure that most of the server frameworks have some sort of implementation for that. And there's also, I think, ImageMagick. I think it's like a pretty standard library implemented in most of the languages that has support for that kind of thing. Okay, I'm going to probably get off the stage now, and we can continue the discussion there, and everyone can take a break. Thank you.